Good afternoon, YouTube. I have a little free time on my hands and I'm putting together some videos about these cantankerous arc lamps, and this particular one is this one's one of my personal favorites. It is a 110 volt DC enclosed General Incandescent carbon arc lamp from approximately 1900 to, I would guesstimate, 1906. The reason I say that is arc lamps around 1903, 1904, the company started streamlining their construction in order to make them less expensive and thus make more profit. So I think this is a little bit earlier than that, but this is just a guesstimate. I have yet to find any catalogs picturing this exact lamp, and this one's just a personal favorite of mine due to it being a DC lamp, which are my personal favorites, as well as indoor. When it comes to arc lamps, I prefer the indoor versions because they're more ornate and they really focus on aesthetics, as you can see here. This particular arc lamp came from the building pictured here, located in Salem, New York, which, upon originally being built, was the Manhattan Shirt Factory. In some of the older pictures, you can actually see at the very front of the building, right above that door, you can see a arc lamp that is most likely the fixture in this video, not the exact fixture, but the same model of fixture. You can see the tubular shape. And when I did get this thing, it had a spherical milk glass globe on it. So seeing the actual light fixture from the building that it was used in and pictures of the building that tied the two together is just really, really cool. The guy that was cleaning the factory out found the fixture, the arc lamp fixture, in an attic, so it was in a really dry area for the past 100 years or so. So in this video, I would like to go over the outside components and then do a brief peek on the inside portion of this beautiful fixture, and then lastly put some voltage on it, and you can see what it looks like in use. So on the very top of our fixture here, we've got the terminal blocks. Notice that they are rather light in construction. We don't have double screws or some inordinately thick build to them, as this is an indoor fixture, so they don't have the heavy-duty terminal blocks on it. This one is marked N for neutral, or the return part of the direct circuit. And then we have our lovely little hanger insulator here with a nickel-plated brass or copper loop squashed around it. And then here is the switching assembly, which I have open as the lamp is turned off for display purposes. And it is marked with a P for the positive, or the positive portion of the direct current circuit. Right below it is the, if we can peek right in there, is the resistance portion of the DC lamp. Direct current has to be regulated with the actual physical resistance. And this particular lamp uses a nichrome resistance coil of approximately 8.5 ohms. This cover right here, I'm not going to take it off with one hand, but if you undo these thumb screws right here, this whole cover right here comes down, and you can make adjustments on the nichrome resistance assembly to tune the arc depending on what type of voltage that you have on the input side. But you can see through the little windows right there. You can see the nichrome coils inside of there, and it's just really, really neat. There are holes cut out into it to aid in convection and keep it cool. During normal operation, the upper portion of the lamp does get quite warm. On the bottom portion of the arc lamp is the solenoid coil assembly that has multiple different taps on it for adjusting the arc voltage on it. Here is an inside look of the General Incandescent arc lamp with the cover removed. You can see the portion of the arc lamp that would have the porcelain insulators that would support the coils of nichrome resistance wire. And then the other cover for the bottom portion of the lamp removed has the solenoid coil assembly. Let's see if we can get these out of the way so you can kind of see that. This is asbestos wound wire, and before any of you freak out that it's asbestos, keep your mouth shut. The stuff has worked perfectly fine for the past 120 years, and any other insulating substance would have degraded and not worked. As long as I don't sit here and play with it and smack on it and snort it like something, it's going to be fine. There's nothing wrong with asbestos as long as you treat it with respect. It's a fantastic insulating material as long as it's treated with respect. The solenoid coil here, you can see it's wound with asbestos, and here's one of the other insulated lead wires to the bottom portion of the lamp. And you can see on the solenoid coil, can you see those little loops right here, here, and here? Those are for adjusting the voltage at the arc. Solenoid coil lifts, here's the lifting assembly that this plunger goes in and out and sucks up and grabs the carbon on the light fixture. So that's the inside portion of this thing. Not very pretty with its outside beautiful shell removed, but that gives you a fundamental overview of the physical working components of this General Incandescent lamp. So now that we've seen the inside of this very beautiful and ornate fixture, let's take a look at the reflective and refractory system on this particular unit. I was able to find a period appropriate milk glass shade with a 6-inch fitter that corresponds with exactly what would be used with one of these fixtures inside, and it looks absolutely beautiful on this lamp. If we look at the trimming access components, if you had a globe on this thing and you wanted to remove the globe quickly, you would use these two thumb screws right here, not thumb screws, but these two latches, and you would undo the latches to remove the globe. But for simplicity's sake, I'm going to remove the globe so you can see the inside components. So it's got these chains that allow the whole assembly to hang off of the lamp for trimming purposes. You see how easy that is to get to? That really is cool. So you let that hang. With this particular open-ended globe, you wouldn't really take it off to access the inner carbons, but a lot of these had ball globes on them, and some had these cone-shaped things. Whatever. It's just to make the lamp easier to work on, and it's just really cool and thoughtful. I love how, if I can capture it on these thumb screws, I can't really get close enough with it to focus, but those little dots, what they look like dots, are actually stars pressed onto the thumb screws, and then you can see the knurling on there to facilitate gripping of that thumb screw on the metal finish. Now, I do want to take note that this is the factory original finish. It's some kind of brass that's been polished and lacquered, and due to where these were stored at in the Salem shirt factory, he told me they were stored in the attic, that the majority of the lacquer is still there. You can see it, and the lacquer kept the brass from oxidizing, combined with the really dry environment. All right, here's the part where all the magic happens. Here's the enclosing globe. I had to have these borosilicate enclosing globes fabricated at a technical glass blower. They're usually glass people that specialize in making laboratory equipment. And with it being borosilicate, it's extremely resistant to the high heat, so I can run this without fear of, breaking the enclosing globe. It costs me about $250 a piece to have each one of these custom made for this General Incandescent lamp. So looking at the enclosing globe here, this whole thing is that they're really trying to design it to make it easy to trim the carbons. What we have here is a spring-loaded assembly. You can see the springs here. These are springs, which I had to replace. The original ones, they were just totally shot, and this whole thing, when I would put the enclosing globe on, it would fall down. So this is an actual stainless steel spring that I bought that fits very nicely back on the enclosing assembly so that you can keep it all put together. The components are nickel-plated brass, and what you do to trim this is you pull it completely down. It'll go down further, but because I have the shade on it, I'm not going to do it, but this is going to give you an idea of how it worked. So we had the gas cap. I fabricated that on my lathe, and it's held on by those little fingers right there. But what you do is you pull this entire thing down, take the bottom carbon out, and then replace the top one, whichever. So another thing is the bottom portion of this. I can't really hold it with one hand. This bottom piece right here, it just I can't really grab it too well. This whole bottom piece right here, it comes out. Can you see that? It just literally sits in there. This whole bottom metal assembly, and then it has a screw. Can you see this? See that piece that screws down? That adjusts the how far up the enclosing globe sits to get a better seal on it. And it's real similar to the GE mechanism, other than the fact that it just literally sits in there. So we're done. We've trimmed the carbons. We're just going to push it back in there. The springs are going to suck the whole thing up, and it's going to work as intended. So with that being said, we went over the outside components and theory of operation and how trimming is done on this particular unit. I believe it is now time to throw the switch on the top, and you can see what this beautiful fixture would sound like. So here's the switch up here on the top, and I'm going to grab it by the insulating portion of it, and then I'm going to throw it in, and it's going to light up. So I just want to take note, this is a DC lamp. For those of you that are familiar with electrical theory, DC arcs don't make any noise. They're completely silent. So if you had a lot of these in your department store or your very, very luxurious house, you would want these fixtures to be silent. You don't want some nasty, annoying 133 hertz or 60 hertz hum with your arc lamp. So I'm going to throw the switch. It's going to be completely silent and beautiful and make a lot of pure, bright white light. So here we go. Look at that. No noise. This lamp is I've got it tuned very well, 73 volts to arc, about 7 amps, 6.5, something in that ballpark. And it runs as it would have in 1900. The carbons are not cored since it's a DC lamp. They're just completely pure carbons, 1/2-inch pure carbons, and it's just a really pleasant, beautiful, bright white light. I would say, in my opinion, this is outputting as much light as a 150 watt incandescent bulb would output. It's not terribly bright, but it's a very pleasing, steady, flicker-free, silent light source that I would be more than happy to have my luxurious department store or opulent house lit up with. So now that you can see it, I'll break the switch here so you can see what it looks like, and then I'll restrike it one more time. great. I can't open the switch and it's drawing an arc. All right, let's try this again here with one hand. All right, there, I open the switch. You can see how hot the carbons are. A majority of the light on these DC lamps, a majority of the light comes from the positive or top carbon in this instance. The center portion of that carbon is about 5,000 degrees Fahrenheit, and that superheated piece of carbon is what makes a majority of the light and reflects it downwards. The arc makes very little light, maybe about 20%, but 80% of the light is made by the superheated carbons. And as they're heated up, this glass enclosing globe keeps a majority of the oxygen off of the arc to prolong the life of the carbons. Typical carbon life on a 1/2 inch arc lamp that is enclosed would be about 100 to 150 hours, which is roughly a new set of carbons every 5 to 7 days. And most people think, oh, that's so archaic, changing out these carbons. Well, you got to think, this is in the era of oil lamps where you're changing out wicks and refilling them with oil, every 1 to 2 nights. So lighting in that time period of 1905, 1906 was something that you were used to having a consumable part. Changing your candles, changing your wicks, filling it up with oil. And from a manufacturing and industry standpoint, who wouldn't want to have a lighting component where you had to change something out? You're going to make money off of it. The power companies absolutely loved it, and the carbon companies, the carbon arc rod companies absolutely loved it. So, it's not during that time period having a lighting device that lasted 5, 6, 7 years before changing it out was not a foreign idea at all. People were used to changing something to get their light. So I'm going to put the globe back on it. I'm going to put that on. I got 2 hands on this. All right, the globe is snapped back on. And what I'm going to do is put some voltage back on this thing. And you can see what it looks like with the shade. It actually looks really, really pretty. Imagine this in your opulent and luxurious department store, turning on without the smell and the hassle of lighting and the dim, nasty kerosene whale oil or gas lamps. This was cutting-edge technology that would be equivalent to having a Star Trek food replicator in your kitchen. So here we go. Look how beautiful that is. It's such a pleasant, crisp white light. You see this purple ring on the shade? That's the ultraviolet radiation coming off of the arc. A majority of it is blocked by the borosilicate glass enclosing globe, so I'm not in any danger of getting skin cancer, rest assured. The only thing that's not historically accurate is this would most likely have an opalescent or milk glass enclosing globe for indoor use, or it would have a completely milk glass or opalescent glass ball shade. That's actually the original configuration for this particular lamp. It had a spherical milk glass shade and a clear enclosing globe. Two enclosing globes did come with it, but they were so badly cracked. However, I had enough pieces in order to replicate it and just basically hand off the broken pieces to the technical glass blower, and he was able to make me a new one for a price. So, but it just utterly beautiful, and the technology is so archaic, yet you've got this superheated plasma stream inside of this extremely elegant fixture. It's just such a beautiful combination of things. I really this really is one of my favorite lamps, and I was so happy to get it working and get some more parts for it. So anyway, I hope you enjoyed this video, and learned something new. If you have any questions, there's the Facebook group, the Carbon Arc Lamp Collectors and Restoration group. And also feel free to leave some comments on my YouTube videos. I do check them and answer it quite frequently. So until next time, I'll talk to you later. Bye-bye.